Hey guys, hello everyone and welcome to the channel. So this particular video is on surface chemistry. It's another part of series of single shot videos. In case if you are new to this channel right now and if you don't know about this series, these are single shot videos which has been started keeping in mind the upcoming CSIR net and GATE exams. So in this video series we are trying to finish simpler topics which are there which can be done in a single shot. So these videos are specifically designed for that, so that in a single go you can revise the complete topic in 20 to 30 minutes, right? So keeping that in mind, we will try to cover surface chemistry in this particular video. The slides has been prepared by Karthik, so I would like to thank him for providing all these slides and preparing them very finely. Thank you so much, Karthik, and a big shout out to you. Now, one more important thing, that if you are new to this channel and if you have not subscribed the channel, please do consider subscribing it. Now, without wasting any time, let's continue with our video. Alright, so surface chemistry is basically the branch of chemistry that deals with the study of nature of the surface or the interface and the physical and chemical changes occurring at the surfaces, and that's what is surface chemistry, right? Generally, the topic which we study in surface chemistry is adsorption. Adsorption is a property, or it's the tendency of the molecule to occupy at the surface than that in the bulk. So if let's say this is a compound, and if these are the if this is the compound on which the adsorption has to be done, so this is called as adsorbent. Okay, so this is adsorbent, and the thing which has to come and get adsorbed on the surface is called as adsorbate. Now these adsorbate are going to come and they are going to bind, or they are going to stay on the surface itself, and they won't be going in the bulk, means they won't go inside. So on the surface their amount will be more, and inside them or inside the adsorbent the amount will be less. Okay, again the definition of adsorbate is the molecular species or the substance which concentrates or accumulates at the surface is called adsorbate, whereas the material on whose surface the adsorption is taking place is called adsorbent. Example is dust particle accumulated on the surface of cloth, different gases of environment accumulating on the surface of charcoal. So these are all examples of adsorption. Okay, adsorption of gases on the metal surface is called occlusion. Okay, so that's the name given to a specific type of adsorption. Types of adsorption comes in two ways. One is physical adsorption, other one is called chemical adsorption. In physical adsorption, the force of attraction between the adsorbate and the adsorbent are van der Waals forces, and the adsorption is called physical adsorption or physiosorption. The examples are like gas adsorbs on the activated charcoal. Chemical adsorption are when the force of attraction between the particle of adsorbate and adsorbent are almost of the same strength as of the chemical bond. The adsorption is called as chemical adsorption or chemisorption. Examples are carbon dioxide and oxygen getting adsorbed on the tungsten surface. So here the force of attraction is more than van der Waals force, and that's why they are called as chemical adsorption or chemisorption. Difference between physical adsorption and chemical adsorption is given on this particular slide. You can see chemical adsorption is irreversible in nature, whereas physiosorption is reversible. Chemisorption is basically caused by chemical bond formation, whereas in the physiosorption the van der Waals forces are responsible for the adsorption. It is highly specific in nature, whereas physiosorption is not specific as such. Chemisorption depends on the nature of the gas. Gases which can react with adsorbent show chemisorption, whereas physiosorption also depends upon the nature of the gas. More easily liquefiable gases are adsorbed more easily. Enthalpy of adsorption is high over here, whereas enthalpy of adsorption is low over here. High temperature favorable for adsorption, it means it increases with the increase in temperature but decreases after a point. So that means if you increase the temperature, the chemisorption is going to increase, but at a certain time or at a certain temperature it is going to decrease after that. Whereas in physiosorption it is low temperature favorable, that means it decreases with increase in temperature. So if you want to plot a graph for temperature versus chemisorption, so if I am plotting chemisorption versus temperature, so this should increase first of all and then decrease, whereas if I talk about physiosorption, so physiosorption and temperature if I plot, so that will be always decreasing, it will keep on decreasing. It results into unimolecular layer of adsorbent surface, whereas in chemisorption multi layers of adsorption can also form under high pressure. There are three more terms which you will come across while studying, that is absorption. Absorption is a phenomena in which substance is uniformly distributed throughout the substance and occur at a uniform rate. Absorption is a bulk phenomenon. Understand this. that in adsorption, it was the surface phenomena on which only on the surface the substance was getting accumulated, whereas in absorption the substance also goes inside the bulk. Desorption, so the process of removing of an adsorbed substance from the surface is called desorption. So it's reverse of adsorption. Okay, so adsorption, reverse of adsorption is desorption. So the substance coming and binding on the surface is adsorption, and removal from the surface is desorption. Sorption is the process in which both adsorption and absorption both are taking place. That means a process in which the substance is going inside the bulk also and is staying on the surface also. For that we call it as sorption. Okay, now we study adsorption on the basis of different isotherms. So there are various isotherms which we have to study. The first one is Freundlich adsorption isotherm. Now Freundlich gave an empirical relationship between quantity of gas adsorbed by the unit mass of solid adsorbent and pressure at a particular temperature. The relationship can be expressed as, now understand that these are called isotherm because they are always calculated at fixed temperature. So that's why they are called as iso, means same, and therm means temperature. So on what factor we are plotting the graph? So we are plotting the graph on amount or the quantity of gas adsorbed versus pressure. So you can see that this is the graph. X by m is the amount of quantity adsorbed, P is the pressure, and you can see that the graph initially it gives you an exponential rise. Okay, so the graph has this formula, or the equation is followed like this: X by m is equals to K P to the power 1 by n. Okay, you can take log both sides, so the equation becomes log X by m is equals to log K plus 1 by n log P, where X is mass of adsorbate, m is the mass of adsorbent, P is equilibrium pressure of the gaseous adsorbate. In case of experiment made in the gaseous phase, that means gas solid interaction or gaseous species and adsorbed species. K is a constant over here. You can also plot the graph for log X by m versus log P. In that case, you will get a straight line. The slope of that straight line will be 1 by n. You can simply look upon this equation. This is being plotted on the y-axis, this being plotted on the x-axis. So the slope of this is going to be this, right? You know that y is equals to mx plus c, and the intercept will be log k. So this intercept will be log k, slope is going to be 1 by n. Adsorption from solution phase. So solid adsorbent can also adsorb solute from solutions also. For example, when a solution of acetic acid in water is shaken with charcoal, a part of the acid is adsorbed by the charcoal and the concentration of the acid decreases in the solution. The following observation has been made in case of adsorption from solution. So it's a very important phenomenon because from the solution itself, you can use some adsorbing agent in order to, or you can use some adsorbent to adsorb the solvent which is present inside the solution. So what are these observations? The first says that the extent of adsorption decreases with the increase in temperature. Second is that the extent of adsorption increases with the increase in surface area of the adsorbent. Third is that the extent of adsorption depends on the concentration of the solute in the solution. And the fourth one is that the extent of adsorption depends on the nature of adsorbate and adsorbent. Remember that these points are only applicable for adsorption from the solution phase. Okay, so when you are adsorbing from the solution, then only these points are going to be valid. So it is kind of, it shows that the phenomena of adsorption from the solution phase is a physiosorption. Okay, the formula which it follows is being taken from the Freundlich adsorption isotherm basically. So X by m is equals to K C to the power 1 by n, where C is the equilibrium concentration, that is when adsorption completes. Okay, so X is adsorbed quantity of solute, that is difference between the initial quantity and the final quantity of solute in the solution, and m is the quantity of adsorbent which you are using. So for example, if you have a solution, let's say, and in this solution I have mixed, let's say, 10 milligram of sugar and in water. Okay, and I am using a adsorbate. Let's say I have a adsorbent whose mass is, let's say, I am using 1 gram of that. Okay, and when I am putting this inside the solution, so what happens that after some time it has been removed. So what is going to happen that, let's say earlier you were having 10 milligram of sugar in the water. After removing this, you got 8 milligrams of sugar in water. So that means how much adsorbate is adsorbed on the adsorbent. So you will say 2 milligram of that is done. So your value of X is going to be 2 milligrams of sugar, and the value of M, that is the quantity of adsorbent, is going to be 1 gram. Okay, so that's what we can substitute here, and C is the equilibrium concentration. So you have to tell the concentration when the adsorption has been completed. At that time, what is the concentration of the solution? K and 1 by N are the constant, and they depend upon the nature of adsorbate and adsorbent. On taking logarithmic, the equation becomes log x by m is equals to log k plus 1 by n log c. So this has been taken from Freundlich adsorption isotherm only and applied on the solution phase. Okay, there are some limitations of Freundlich adsorption isotherm as well. Experimentally, it was determined that the extent of gas adsorbed varies directly with pressure, and then it directly varies with the pressure raised to the power 1 by n until saturation pressure Ps is reached. Beyond that point, the rate of adsorption saturates even after applying the higher pressure. Thus, Freundlich adsorption isotherm fails at high pressure. So at high pressure, the Freundlich adsorption isotherm does not work. So that's one of the limitation of it. So to overcome those limitations, Langmuir adsorption isotherm was bought. So Langmuir adsorption isotherm made following assumption. What's the first assumption? It says that the layer of gas adsorbed on the solid adsorbent is one molecule thick, or you can say monolayer. Okay, so they have assumed that there is just one layer formed. Then the adsorbed layer is uniform all over the adsorbent. That is the second assumption. And the third assumption is that there is no interaction between the adjacent adsorbed molecule. Means if this is the adsorbent and these are the adsorbed molecules, so the molecules are not going to interact among themselves. Okay, molecule can interact with the adsorbent, but they cannot interact among themselves. Alright, so the formula goes in this way, that if theta is the fraction of total surface covered by the adsorbed molecule and K is the equilibrium constant, then it is referred to as the adsorption coefficient, and pressure P of the gas, okay, K is basically then, and K over here is missing. So K is referred as the adsorption coefficient and pressure P of the gas, then theta is equals to Kp upon 1 plus Kp. And the amount of gas adsorbed per gram of the adsorbent X is proportional to theta. You can also have that theta is equals to K dash Kp upon 1 plus Kp, where K dash is a new constant. Alright, so according to our Langmuir adsorption isotherm, at low pressure, you can have in the denominator this 1 will be very much greater than Kp. Then the equation is going to follow in this way, that your theta is going to be proportional to P. Theta is the surface coverage, and you know that theta is proportional to X and X is proportional, like theta is proportional to P. So you can say that X is proportional to P. Okay, that is happening at low pressure. So X is proportional to P at low pressure. So that's why you are seeing that it's a first order reaction initially. Whereas at high pressure, when you are taking pressure high, in that case, in the denominator 1 plus Kp, you can assume that Kp at high pressure, this will be very much greater than 1. So you can remove this 1, and then in the denominator you will only have Kp. Kp will get cancelled out, and you will get theta is equals to 1, or you can say that theta is proportional to some constant, and since X is proportional to theta, so you will say that X is equals to some constant. Alright, so that makes X is equals to constant. So if I plot X is what? X is basically the amount of gas which is adsorbed per gram of the adsorbent. Okay, that's X. So the amount of gas adsorbed versus pressure, if I am plotting, so initially it is first order, that is at low pressure it is first order, but at high pressure it becomes zero order reaction. The next equation and the most advanced equation which we use is isotherm equation for multi-layer adsorption of gas, or also called as B.E.T equation. Now there were certain postulates for B.E.T theorem also. The first postulate says that the adsorption involves the formation of a multimolecular layer rather than monomolecular layer. Second says that the Langmuir's idea of fixed or localized adsorption site was retained, means it was also retained here also, that there is a fixed site of adsorption and the molecule is not going to change its site during the adsorption. The third assumption was that the interaction between the adsorbate molecule in the adsorption layer are neglected. Fourth says that for the formation of single complexes, the assumption made in Langmuir's theory is adopted. Fifth is that there were dynamic equilibrium between the successive layer. The rate of evaporation desorption from the first layer is equals to rate of condensation on the preceding layer. So these were certain assumption which has been made by the BET, because they were dealing with multi-layer, so they have to take certain assumptions to understand it. The next statement says that after the first layer, the heat of adsorption is equal to the latent heat of condensation of vapor. Now, on the basis of all the above assumptions, Bronner, Emmett and Teller, they are only BET. So that's why it is called BET theorem, isotherm. So they derived the equation which says that P divided by V P naught minus P is equals to 1 upon Vm into C plus C minus V upon Vmc dot P upon P naught. And this is called BET equation. What are the terms over here? So V is the volume reduced to the standard condition of the gas adsorbed at some pressure P and some temperature T. Okay, so P is the pressure, T is the temperature, V is the volume. P naught is the saturated vapor pressure of the adsorbate, that is gas or vapor, whatever you have, at the temperature T. Vm is the volume of the gas reduced to standard condition at NTP, adsorbed to form the saturated monolayer per gram of the adsorbent. So Vm is basically the volume of the gas required to form the monolayer, and C is a constant. Now BET equation suggests that if we plot the equation for P upon V, P naught minus P versus P upon P naught, it should give a straight line. This has been found to be so experimentally correct, okay, which confirms the correctness or the validity of BET equation till date. So you can see that if you plot this versus this, you are going to get a straight line whose slope is going to give you C minus 1 upon Vm into C, and the intercept should be 1 upon Vm into C, and that's what this equation also tells you. So the slope of this is C minus 1 upon Vm into C, and the intercept is 1 upon Vm into C. So what you have to remember is the formula of BET theorem. From BET you have to remember that, and second thing is that what does the slope of BET theorem suggest and what does the intercept tells you. Okay, so using them, how you can calculate the rest of the things, that you have to do. And remember that slope plus intercept, if you do, you get 1 upon Vm. Okay, this is also one of the important thing which you can take from BET theorem. One thing at the end which I will add over here is that in your Langmuir adsorption isotherm, if in case there is some some dissociation or association is happening, in that case the formula converts into theta is equals to Kp to the power 1 by n divided by 1 plus Kp to the power 1 by n, where n is the number of molecule in which the desorption or adsorption is happening. Okay, so if let's say there is a molecule while adsorbing, it also dissociates into two molecule, then n value is going to be 2. Alright, so if the dissociation or association happens, that is going to change the value of n, that's it. Let's at the end talk about some of the limitations of BET theorem. So the assumption that the adsorbate has liquid properties is not correct. The adsorbate can have any property, so that assumption was not correct. Second point, that when the net heat of adsorption, that is E1 minus EL, is low, the constant C in the BET equation is small. At C less than 2, the BET equation gave a concave isotherm. Okay, concave isotherm means it's not going to give you a straight line but a curved line like that. Okay, so BET equation holds good when P upon P naught values lie between 0.5 to 0.35. This equation fails if the P by P naught is below 0.5 or above 0.35. So this thing you have to know, that if P by P naught is between this range, then only BET theorem is very much correct. Coordination number of the molecule in the higher layers also add to the criticism of the BET equation in another way. And the last point says that the low adsorbent energies, however, the adsorbent interaction cannot be neglected. In these cases, the isotherm, that is curves, are more complicated in the shape. So BET has assumed that the energy between the adsorbate and adsorbent is low. However, it's not true. You should not neglect that, and if you are neglecting it, that's why you are getting a straight line. Otherwise, the curve is going to become more complex. These were certain points and certain formulas and equations which you need to remember from the surface chemistry portion. The rest of the part contains colloids and the properties related to them. I will cover them in some other single short video. I hope for this video it's enough to be finished, and I hope this thing summarizes the majority of the part of physical, or you can say the physical part of your surface chemistry, or you can say adsorption part of your surface chemistry. And I hope that this video makes sense to you. Thank you so much for watching this video, and I will see you guys in the next one. Till then, have a great day. Bye bye, take care.
Hey guys, so I teach live on Uncademy Plus platform. Here I teach for the CSIR UGC NET category, and you can follow me over here for regular classes. You can access my free classes as well as my paid classes on this particular platform. The classes which are free, you can get that under the section of special classes, whereas in order to access my paid classes, paid live classes, you have to take Uncademy Plus subscription. So do make sure that you take the Uncademy Plus subscription to access all my paid classes, which are quite organized. The whole syllabus is being completed over there and the classes are quite regular over there. So make sure that you take Uncademy Plus subscription by using my referral code, that is N_Huda. That's it for this. Thank you so much.